Hi, and welcome to this presentation on SQL Server 2012 Always On Availability Groups. My name is Edwin Sarmiento, and I'm a SQL Server MVP and Microsoft engineer based in Ottawa, Canada. Let's get started. SQL Server High Availability has come a long way. I've been working with SQL Server 6.5 and 7.0, and I've seen how the features have evolved, where SQL Server has started addressing high availability and disaster recovery requirements. Let's take a stroll down the memory lane and take a look at those features. Failover clustering provides SQL Server instance protection and high availability, which means your entire server is protected and can be running on any node within a failover cluster. Now, SQL Server, though, takes advantage of the Windows failover clustering feature as its platform. Now, understand, though, that configuring, setting up, and administering failover clustering is not pretty straightforward. In fact, when it was introduced way back in Windows NT4 days, it was pretty difficult because you now have to worry about hardware compatibility list, making sure that your drivers and hardwares are certified not just by Microsoft and running on top of Microsoft Windows, but also making sure that these drivers and hardware are certified for Windows failover clustering. The good thing about this is you are providing an instance level protection for SQL servers. You've got like 100 databases. All of those databases are protected. But you have to deal with shared storage, shared network, and of course, more nodes or servers to provide availability for your SQL Server instance. And then you got log shipping, the concept of taking regular log backups, copying those backups on a standby server, and then restoring them on a constant basis. This is happening via SQL Server agent jobs. And of course, when the backups are running on regular intervals, the data being copied from the primary database to the standby database is not synchronized, which means you have to deal with a time lag between the backup process, the copy process, and the restore process. Not to mention, of course, that you have to deal with log shipping on per database level. Which means if you compare Windows failover clustering or SQL Server failover clustering with log shipping is a bit more tedious because you have to repeat the process per database. Let's say you've got 10 databases. You have to configure log shipping on all those 10 databases. Add 5 more, that means you have to repeat the process 5 times more. But it's a cheaper way to provide high availability and disaster recovery for your SQL Server instance as compared to failover clustering. A lot of customers use replication as an option to provide high availability and disaster recovery for their SQL Server databases. Again, you do it on a database level. I'm not really a big fan of replication as a disaster recovery and high availability option because it wasn't intended and designed to be like that. But some customers managed to get it working because they understood the underlying features and internals of how replication works. SQL Server 2005 introduced the concept of database mirroring, in particular after Service Pack 1. This gives customers an option to provide high availability, data synchronization, and at the same time not as expensive and complex as Windows failover clustering. All of a sudden, I see a lot of customers moving their SQL Server instance implementation for high availability and disaster recovery from either failover clustering or log shipping into database mirroring. In fact, even to provide data redundancy on top of failover clustering, they combine this with database mirroring to provide geographical availability for the databases. Now, all of a sudden, database mirroring becomes a rock star. I've seen a lot of customers started implementing database mirroring ever since Service Pack 1 and SQL Server 2005 was released. As a DBA, you became a rock star because you now started to implement these solutions. And again, providing high availability and disaster recovery solutions to your highly critical databases. However, just like any other feature or technology implementation, it's not without its challenges. One of the things that I've seen a lot of customers tell me when it comes to implementation of database mirroring is that they can't maximize the resources. Just like with failover clustering, where the SQL Server instance is running on only one node at any given point in time, the other node is really not doing anything. And in this case, with database mirroring, you can't even run an application on top of the mirrored database. As a quote from an efficient CIO I've heard one time, I can't maximize resource utilization on the mirror server. To demonstrate that, I have a typical database availability option where I've got 3 SQL Server instances running on 3 different servers, all default instances. I've got 2 databases, Demo Sales DB and Membership DB, configured with database mirroring. The principal running on SRV1 and the mirror running on SRV2. Now I've got an application that I wrote that I wanted to use to query data on the mirror database, just so I can offload reporting applications from the primary database or the principal database to the mirror database. Unfortunately, with database mirroring, I can't do that because the mirror database is in constant recovery mode, which means I can't even log in, I can't even run a select statement off of it. Unlike, of course, with log shipping, where I can configure the database, the standby database, to either be, number 1, in constant recovery mode, or number 2, in standby mode, which means I can run select statements or run reports on the standby database during the times that my log backups are not being restored. So that's one of the biggest challenges of having a database mirroring configuration. We can't just maximize resources. Second challenge is having multiple copies of data. There may be several compliance requirements where you need to have multiple synchronized copies of the database. With database mirroring, you can only have one extra copy of the database. Whether it's synchronous copy or asynchronous copy, you can only have, again, one mirror copy of the database. If you want to have more than one extra copy of the database, you're stuck with configured log shipping, which is exactly what I have in my setup. I've got the Demo Sales DB configured with database mirroring from SRV1 and SRV2 acting as a mirror hosting the mirror database. But since I want to provide high availability for my other database and having multiple copies, I had Demo Sales DB configured with log shipping, with SRV3 acting as my standby. And again, that's one of the challenges of having database mirroring, because again, you can only have one extra copy, whether it's synchronized or asynchronized, of the database. The third one is seamless failover. And this is something that I've heard a lot of, not just customers, but application vendors say that they don't automatically support or support automatic failover and database mirroring. I've talked to a lot of them, and one of the things that pushes back a lot of customers is that when they want to implement database mirroring, they had to work with either their network guys, their systems admins, to come up with workarounds to address the failover of the databases in database mirroring. Application vendors don't support that. Well, probably not all of them, but still, you have to worry about those challenges. That is why most of the application vendors still go with failover clustering, because everything's transparent. They configure their application to use a virtual server name in the connection string. And of course, failover clustering is responsible for moving the virtual server name, the virtual IP address from one node to the other. The application doesn't have to worry about that. Now, as a DBA responsible for maintaining, implementing, and providing these solutions to your customers or your internal database platform, you ask, what do I do? I've got more than enough problems to deal with every day. Introducing a new feature in SQL Server 2012 called Always On. Now, there are two major categories of SQL Server 2012 Always On. One of which is failover clustering. This is when you want your SQL Server be stretched across geographically dispersed locations. While Windows Server 2008 and Windows Server 2008 R2 supports geo-cluster implementation where you have multiple nodes across different locations, SQL Server 2008 and SQL Server 2008 R2 do not support that. Which is why if you want your SQL Server to be stretched across different geographical locations, you have to implement a virtual LAN. Now, this is not going to be what we're talking about for this presentation. The focus of this presentation will be all about availability groups. So let's get started on looking at how we configure always-on availability groups to my existing environment. Just to give you a quick, of course I already did, just to give you a quick overview of my setup. I've got database mirroring configured between SRv1 and SRv2. Two databases are configured with database mirroring, so I have synchronized copy of my database on my mirror. And then just to provide an extra copy, not necessarily synchronized, I had log shipping configured for demo sales DB and membership DB on SRv3. Now what I'm going to do is I'm going to convert both database mirroring and log shipping to always on availability groups. But before I do any of that, let me disable my log shipping configuration and disable database mirroring prior to converting them to always on availability groups. So for now, let me just disable log shipping on the primary instance. Let me copy this. And again, it's just disabling my log shipping jobs. The reason I'm doing this is because I don't want another log backup job truncating the log and causing inconsistency between my log sequence number. So let me run that off and disable the log shipping job on my primary. Let me do that on my standby and disable log shipping jobs on the standby. Disable this on the standby, which is SRv3. Okay, now I'm sure that all my log shipping jobs have been disabled. The first thing that I need to do to configure always on availability groups is enable failover clustering on my Windows Server infrastructure. Now note though that I don't really need the full-blown Windows failover cluster with shared disks, shared network and stuff like that. All I need is just to turn on the feature so that SQL Server can leverage on that platform. So let me open up Server Manager and enable failover clustering feature on the server. Now you have to do this on all of the servers that you want to participate in your availability group. In my case, I've already enabled the failover clustering feature on both SRv2 and SRv3 just to minimize the time required to do that. So I'm going to enable that feature, in this case the failover clustering feature, on all of the nodes. Now before I do that, let me highlight that if I want to take a look at my SQL Server Configuration Manager, you will see an extra tab on my SQL Server Service property called Always On High Availability. Note that now it says this computer is not a node in a failover cluster, which means we really have to turn on the Windows failover cluster and create a Windows failover cluster for SQL Server to leverage on that and turn on Always On availability groups. We'll come back to this later on. And we'll install it. This simply enables the failover clustering feature on the Windows operating system on which SQL Server is running on. After the feature has been enabled, we then create a cluster using, in my environment, SRv2, SRv3, and SRv1 as nodes in my failover cluster. Now while waiting for this, we just think of a virtual server name and a virtual IP address that we can use for the Windows failover cluster. Once we have that, we now have the Windows failover cluster as part of our management console. We can go ahead and create a cluster, provide the virtual server name for the Windows failover cluster. Let's call this Denali cluster, or rather Denali SRv1, which is the host name of the machines that I want to include in my failover cluster. We'll add both Denali SRv2 and Denali SRv3 on the failover cluster. We'll add those two servers as well. And we can go ahead and just create the cluster. We then have to provide the option to either validate the cluster or not. I strongly recommend that you validate, but for the purpose of this presentation, I can go ahead and ignore the validation simply because I've done this test a couple of times and I'm using the same old machines that I've used in my previous demos. I'll provide a cluster name. This will be the Windows virtual server name that you can use to access the failover cluster for management purposes. And we'll provide a virtual IP address. This page gives you a summary of all the information you provided, the Windows virtual server name, the different nodes that form the cluster, and the virtual IP address. We'll click next, and this will go ahead and add those servers in the Windows failover cluster. This also creates the Active Directory object for the Windows virtual server name and DNS entries for both the virtual server name and the virtual IP address. And that's how simple it is. You now have a working Windows failover cluster. You can expand the Failover Cluster Manager node and take a look at the different properties of your cluster. You currently don't have any service and application. You have the different nodes, the Denali SRv1, SRv2, and SRv3 as your nodes in your Failover cluster. I don't have shared storage because they're just standalone instances. I'm not even using cluster disks for the specific feature to work. And I've got my network. Now that Windows Failover clustering is enabled on this Windows machine, I can go back to my SQL Server Configuration Manager, open up the SQL Server Service Properties, and go back to that Always On High Availability tab. Notice now that I have my Windows Failover cluster name registered within the SQL Server Service Properties, and you can always enable Always On Availability Groups by checking this checkbox. Click on Apply, and this will prompt you to restart your SQL Server service. So let me restart my SQL Server service at this time so that my changes will take effect. While this is running, I don't want to log into SRv1, rather SRv2 and SRv3 just so to check that checkbox, restart the SQL Server service. The good thing about this is that the SQL Server team provided us with an option to do it via scripts. And this is where we can enable Windows Failover clustering commandlets using PowerShell together with the SQL Server PowerShell commandlets. So let me start PowerShell with this. And from within PowerShell, we can use the enable SQL Always On PowerShell commandlet to perform specific tasks on SRv2 and SRv3. Now from within SQL PowerShell, we can then use the enable SQL Always On PowerShell commandlets to enable Always On availability groups on the other nodes in my Windows Failover cluster. I've got a script for that. I'll enable SQL Always On for both nodes. So this will execute the enable SQL Always On PowerShell commandlet on those nodes and then restart the SQL Server service. At least I don't have to log in to those servers remotely via remote desktop, opening up SQL Server Configuration Manager, opening up the Always On Availability Group properties in my SQL Server service, just so to enable that feature. Once that's done, I'm now ready to configure and enable convert my databases that are previously configured with log shipping and database mirroring to Always On availability groups. Let me go ahead and disable database mirroring on those two databases. So these two commands just disables database mirroring for my demo sales DB and membership DB. So now I've fully disabled log shipping and database mirroring on all of my databases. Let me go ahead and under Always On High Availability, let me just do a quick refresh and create a new availability group. Let's use the new availability group wizard. This will walk me through creating a new availability group. I'll click on next. I'll provide an availability group name. I'll call it Always On AG Prod. I'll use both demo sales DB and membership DB as part of my availability groups. The good thing about availability groups is now you are configuring a database or a group of databases to be a part of an availability group. Unlike with database mirroring, when you do a failover, it has to be done on a per database level. Which means if you're dealing with applications that connect to multiple databases, a classic example here is SharePoint. If you want to fail over to the mirrored instance, you would have to fail over all of the databases one at a time. With availability groups, you can put the databases into a group and then fail over a group, which means failing over a group takes care of failing over all of the databases within that group. So I'll select the demo sales DB and a membership DB. I'll click on next. I have the replicas, in this case they're called replicas. I'll configure Denali SRV1 to have automatic failover, synchronous commit, enable read-only secondary. I will talk about read-only secondary later on as part of my demo. I'll add Denali SRV2, which is my second node in my failover cluster. I'll configure the same thing. I'll have automatic failover for Denali SRV2. I'll also configure it for readable secondary. Same thing with Denali SRV3. I'll have the third one to use synchronous commit and configure read-only secondary as well. Notice that at this point I now have 3 synchronous copies of my databases. I can have an extra one, although the 4th one will have to be in asynchronous mode. You can go ahead and look at the endpoints. In this case, since these databases have been configured initially for database mirroring and log shipping, I can take advantage of those endpoints and use them for availability groups. I won't talk about backup preferences at this point, as well as listener. I'll talk about the listener tab in the demo that I'm going to be doing later on. I'll click on next. Since these databases were part of database mirroring session and log shipping configuration, I don't have to synchronize the data or initialize the data. If you are working on a new database, you have to do the initial data synchronization phase. This is where you do a full backup and a log backup of your database from the primary and then restore those on the secondaries. I'll click on next. Just going through the notion of checking the network location, compatibility, and so on and so forth. Click on next. I can either script the entire process or just let the wizard run on itself. I'll click on finish for the wizard to take care of the rest. Notice that it's now in the process of configuring the endpoints. Of course, it's no longer going to configure the endpoints because these databases were running in database mirroring and log shipping configuration prior to me converting them to always on availability groups. So it's going to leverage those endpoints for availability groups. A couple of steps have been skipped because we didn't choose to initialize the data for this purpose. I'll click on close. Now I do have my always on availability group named always on AG prod. Got 3 servers acting as my replicas. Now I've got my databases, demo sales DB and membership DB. Let's go ahead and look at Denali SRV2, which is my second replica. They have been configured as well. So now you see always on AG prod on my secondary. Replicas are also defined. However, the databases here are not joined. The reason for this is, again, the data initialization phase was not done, so we have to manually do this. I'll join this database to the availability group. Same thing with a membership database. And I'll do the same thing for Denali SRv3. Let me do a quick refresh on my user interface. Do a quick refresh. And on the databases, again, join Demo Sales DB and my membership database to the availability groups. If you look into this, I now have more than 2 extra copies, 2 extra synchronized copies of my databases. And now I can go back to my application that I was running earlier. The application that can't connect to the mirror database because it's in constant restore phase, and run a query. Note that my server instance name points to Denali SRv2, which is my secondary. My primary here is still Denali SRv1. Let me go back to the other application and point to Denali SRv1. If you look at it, now I'm maximizing my resource because what used to be a mirrored database that I can't even run a query on is now accessible using always-on availability groups. Let's have a look at how we can simulate traffic or transactions on the specific database. We'll look at a typical transaction for the Demo Sales DB database. And this is just a simple insert statement. I'm using the instance name, in this case a local host, to point to Denali SRv1, and I'll insert sales customers information on Denali SRv1. And I want you to pay attention to how transactions are being replicated over from Denali SRv1 to Denali SRv2. It's almost instantaneous. And this is the beauty of having synchronous copies of your databases via always-on availability groups. So now I can run a query on my, let's call it the mirror database, and have almost instantaneous or almost real-time copy of the data being brought back to me on my, let's say, a reporting application, because technically we can't run any insert, update, or delete statements on the replicas, only on the primary. Let's simulate a failover. Let's use SQL Server Management Studio and initiate a failover for the availability group. Right-click on availability group and select failover. Let's go through the wizard. We'll select an instance that we can use as the failover node for the availability group. We'll connect to Denali SRv2 because we want to failover to that instance. Click next. I'll script this because I want to use the same script to failover and fail back. I will enable SQL CMD mode because I want to connect between Denali SRv1 and Denali SRv2 just so I can do failover. Do that. Notice how my applications are now getting terminated. Of course, it's but natural for those applications, even with failover cluster where the clients get disconnected. Of course, if the application has a reconnect logic after every disconnection, it will reconnect back. if you click on the start, I still get connections to Denali SRV2, still on Denali SRV1. Unfortunately though, my applications won't be able to, the transaction applications won't be able to connect back because they're still looking for the old name. In this case, the SQL Server instance name, which is Denali SRV1. Let's fail over this availability group back to Denali SRV1. And again, having those clients disconnect because of the failover process, then we can connect back in. One challenge there is having your applications to seamlessly fail over when your availability group fails over. This is where we start using the listener that you've seen in one of the tabs earlier while we were creating the always on availability group. So let's go ahead and add a listener. Let's name it always on AG con. I'll use a static IP for this. I'll use port 1433. I'll add an IP address. Imagine this as your virtual IP address, similar to what we had earlier when we were building our failover cluster. Click OK. And this will create the always on AG_con as my virtual server name, in this case my listener, with the virtual IP address and my port number. Click on OK. This will create my always on availability group listener name. Let's go back to the applications and use the always on availability group listener instead of the instance name. Let's use the same name for the other client application, replacing the instance name with the listener name. It still works, but note how the instance name here started getting redirected from Denali SRV2 to Denali SRV1. Same as with this one, because now you're looking at a virtual server name that gets redirected to the primary instance or primary replica. Let's do the same thing with the batch file that we were using earlier. I'll modify the instance name. Instead of using localhost, I'll modify this to use the always on availability group listener. This will now take care of getting redirected to the correct node or the correct server, in this case the correct instance, hosting my primary replica. We'll generate a transaction again, seeing my transactions going to Denali SRV1. Of course, this one's getting redirected to Denali SRV1. We can stop this again, try changing it back to Denali SRV2, just so we can see how the transactions are getting forwarded to my secondary replica. Connected to server property gets changed back to the instance name, and notice how the data gets updated on a synchronous fashion. Let's go back to the tsql command to fail over our availability group. Again, same thing as what happened earlier. Clients get disconnected because of the failover. But this time, when I try reconnecting the applications, particularly the batch file that I was running earlier, it gets seamlessly converted back. Notice how even though my data source points to the always on availability group listener, my instance name now points to Denali SRV2 because now after failover, SRV2 has become my primary replica. We can do the exact same thing in fail back from Denali SRV2 to Denali SRV1. The same thing happens. You can retry your applications after the failover, and you don't have to worry about renaming your applications. And notice that this client application is now connected back to Denali SRV1. You've now seen how Always On Availability Group has addressed those challenges that we've seen with database mirroring. You can now run queries against your mirrored database. Of course, in this case, they're now called secondary replicas. And you can now configure your application to use Always On Availability Group listener name to provide seamless failover when the databases get failed over between instances that are acting as nodes within your failover cluster. In this case, replicas of an availability group. In summary, we've looked at always on availability groups to maximize your resources, have multiple copies of your data. Now instead of having one database mirroring configuration and log shipping, you just have always on availability groups to provide you with multiple copies of data. In the demonstration, you've seen 3 synchronous copies of data in 3 different SQL Server instances. And finally, you've seen how seamless failover happens when you configure always on availability group listener and use the listener name for your connection strings in your application. That's always on availability groups. Next steps, SQL Server 2012 RC0 is available. You can download and play around with it. Try converting your database mirroring and log shipping configuration to SQL Server 2012 always on availability groups, similar to what I've done in the presentation. And have a look at these specific URLs on what always on availability groups are, how to get started with always on availability groups, and you can check out the always on FAQ for SQL Server 2012. With that, thank you.